All right, so my group did FRQ question number 14, which was about periodicity. So our question, suppose that a stable element with an atomic number 119 or symbol Q has been discovered. Write a ground state electron configuration for Q using noble gas notation. So we found that element 118 is a noble gas. Its symbol is OG, and knowing that 119 is the one directly after that, we know that it only has one electron in the s orbital, and it'll be in its 8th shell because it is in the 8th period of the periodic table. So there, put OG 8s1. Would Q be a metal or a non-metal? So we can know it's a metal because, again, it is in that first group, which is the alkali metal group, or based on this chart, you can clearly see that it would be down here and it would be obviously a metal. Would Q have the largest atomic radius in its group or the smallest? Would Q have the largest atomic radius in its period or the smallest? So in its group, we can derive from this chart, knowing that atomic radius increases as we go to the left and increases as we go down. We know that it would have the largest atomic radius in its group because it would have the largest amount of energy shells. And we would know that it would have the largest atomic radius in its period because of the attraction would be the lowest for any alkali metal in group 1. So then what would be the most likely charge of natural Q ion? So yet again, it is an alkali metal, and all alkali metals will have a natural ion of +1 to make their outer valence shell become full. It will give up an electron to become a +1 charged ion. So then write a balanced reaction of solid element Q with water. So first off, we need to yet again know that Q is an alkali metal. So we can say that an alkali metal plus H2O will always go to that alkali metal bonded with a hydroxide polyatomic ion and H2 gas. And then once we have that, we can just simply balance it. You know, we have 3H on this side, so we need to put 2 here to get to 4, but then because of that, got to put a 2 here to make this even, and then we put a 2 on the Q to just balance the entire thing out. Then write a formula for the compound of Q and a carbonate ion, which is CO3 2-. So up here, we said that Q is a +1 natural ion, and to get it to a 2-, we need to say that there are two Qs to cancel out this 2-. And then should Q carbonate compound be soluble in water? So based on the solubility rules, we know that all group 1 elements will always be soluble, meaning that this compound will be soluble in water. All right, and that's our question.